Hello everyone, we are going to start our class. In the introduction class, we have already discussed the detailed about the question pattern, exam pattern, and the syllabus of the set examination. Now we are going to start our first class in the set paper 2 physical science. In the physical science, we start with mathematical physics. We start with mathematical physics, and our first lecture is about dimensional analysis. If you go through previous set purpose, as I told you in the last class, the set syllabus is identical across the state, and except in Kerala, all other state, the exam pattern is also same. In the Karnataka state eligibility test, Maharashtra state eligibility test, or Rajasthan state or MP state, whatever it is, the exam pattern and syllabus is identical. In these states, the paper two question paper have each question carries 2 mark. Okay, so 2 mark question. In the Kerala, it is a 1 mark question, and that is explained in the last class in detail. Okay, so as I'm giving the online coaching for set, net, and gate for last few years, last 5-6 years, I'm giving online coaching for set, net, and gate. So I'm actually going through the papers of all state. So I can see that the dimensional analysis, this topic is not that much important compared to other topic. This topic is not that much important. Still, you can find, even though it is not, the question is not asking in each and every year, you can find questions from the dimensional analysis also. So we cannot ignore this because even though it is a simple subject, questions are not asking each and every year, but there are questions in the from the dimensional analysis in the Karnataka state eligibility test, Maharashtra state eligibility test, and Rajasthan state eligibility test, and also in other TN set also you can find questions related to dimensional analysis. So totally there are around 10 questions from mathematical physics. Minimum, if you go through the minimum number of question, it is 8, and the maximum number of question it go to 12 also. So average number of question from the mathematical physics is 8, and you can expect and question 1 or 2 questions from the dimensional analysis also. Okay, so in this class we explain the each and every type of problem that can be asked or which is already asked in the set state eligibility test. Okay, so in the dimensional analysis, first thing we have to know is the fundamental physical quantities and their dimensions. So according to SI units, there are 7 fundamental physical quantities. All other quantities are not fundamental, it is derived, called derived quantities. All other quantities in the physics like velocity, acceleration, energy, work, electric field, magnetic field, whatever it is, all other quantities are derived from the fundamental quantities. There are 7 fundamental physical quantities, in which the first one is the length, and length is the symbol is usually represented by small l. The symbol is not important for us. The dimension is important for us. The dimension of length is represented by a capital L in a square bracket. So whenever we write a dimension, we always write this letter in a square bracket. And second one, mass. Mass is the dimension of mass is represented by capital M in square bracket, and dimension of time is capital T, and dimension of electrical current is a capital I. Dimension of temperature is a capital theta, and amount of substance usually represented by mole, small n, and its dimension is represented by capital N. And luminous intensity represented by capital J. In these quantities, for us, the dimension of the L is important, mass is important, time is important. These three are most important because in the most of physical quantities these three come, especially in the classical mechanics. And the electric current usually come in the dimension of dimension related to the quantities in the electromagnetic theory. And theta capital theta, that is the temperature, that dimension usually come in the terms related to statistical thermodynamics, and also n, that is also in that topic. And luminous intensity is related to in modern physics, but I find no questions related to luminous intensity in any state. Okay, so these are the 7 fundamental quantities and their dimensions. Based on this, now what we actually mean by dimension. So in dimensional analysis, a dimension tell you that the nature of physical quantity in terms of fundamental quantities like mass, length, time, etc. That is, it means that how a physical quantity depend on mass, length, time, and other fundamental quantities. So for example, look, here I will give you some example. For example, look, velocity. We know that velocity is displacement by time. Displacement actually representing length and time is representing time only. So the dimension of velocity, here you can see dimension of velocity is length by time. In the square bracket, length by time. This can be written as L t power minus 1. Dimension of velocity. Dimension of velocity is L t power minus 1. Okay, if you write in the MLT format, then it will be, there is no mass here, so m raised to 0 L power 1 t power minus 1. So that is the dimension of velocity. So for in this dimensional formula, we get know that how velocity depend on the fundamental quantity, length, and time. Okay, for another example, acceleration. Acceleration, we know that velocity by time. Acceleration is actually average acceleration is final velocity minus initial velocity upon time. So actually it is a quantity velocity upon another quantity time. And we already know the velocity is L t power minus 1 and time is t. So this become L t power minus 1, and the denominator 1 by t, when it comes to the numerator it also become t power minus 1. So this will be equal to L t power minus 1 into t power minus 1 equal to t power minus 2. So L t power minus 2. That is the dimension of acceleration. What is the dimension of force? We know that force is equal to mass into acceleration. The dimension of mass is a fundamental quantity. So dimension of mass is m, and dimension of acceleration we already derived, that is equal to L into t power minus 2. So the net dimension become m power 1, L power 1, and t power minus 2. That is the dimension of force. Now another example, work and energy, very important. Work is the work is actually energy only. Work is the force into displacement, and energy both are same thing. So work and energy have same dimension. So work we can we know that work is equal to F dot S. So force into displacement. So the dimension of work is equal to force into displacement. The dimension of force is equal to ml t power minus t. We already done t power minus 2 m into L t power minus 2. And displacement is a length, so into L. So m L into L become L square into t power minus 2. So m L square t power minus 2 is the dimension of energy. Okay, next, dimension of power. Dimension of power, we know that power is the rate of change of energy, or energy by time, or work by time. So power is the work by time or energy by time. So dimension of power become dimension of energy or dimension of work upon time. So dimension of energy is ml square t power minus 2 upon t. So this become look at t power minus 2 m l square t power minus 2. In the denominator also we have a t. So when it comes to the numerator, it become t power minus 1. So net we will get m l square t power minus 2 minus 1 equal to t power minus 3. T power minus 3. So ml square t power minus 3. That is the dimension of power. Now dimension of momentum. We know that momentum is mass into velocity. Dimension of mass is capital M only. Dimension of velocity we have already done. L into t power minus 1. So dimension of momentum become ml t power minus 1. Pressure. We know that pressure equal to force upon area. So dimension of force equal to ml t power minus 2. Dimension of area. What is area? Length. Length into length. Area of a square equal to its length into breadth. Area of a rectangle, length into breadth. Area of a circle, pi r square. Pi is a constant, it has no dimension, and r square is equal to radius into radius. So dimension of area is always square of the length. So this become ml, and here we have denominator l power 2. So when it comes to numerator, it become l power minus 2 into t power minus 2. So this become m 1 minus 2. So that become minus 1. ml raised to minus 1 t power minus 2. So that is the dimension of pressure. Now dimension of gravitational constant. This is asked in the one of the set examination. Dimension of gravitational constant. We know that force equal to gravitational force equal to gravitational force is directly proportional to product of masses m1 into m2 and inversely proportional to square of distance between them. It means that it is proportional to 1 by r square, and the proportionality constant we write as g. So what is the dimension of g? So here if we cross multiply, we will get g equal to f into r square divided by m1 into m2. So dimension of g becomes dimension of force into dimension of r square upon dimension of m1 into m2, m into m. Dimension of mass into mass, m square. So upon m square. So that become m power 1 upon m square equal to m power minus 1, and l into l square l cube into t power minus 2. So m power minus 1, t power minus l square 3, and t power minus 2. That is the dimension of gravitational constant. It is asked in one of the set examination. Now heat energy. Heat energy is another form of energy. So heat energy have same dimension of energy. Now this is another question which is asked in the examination. Specific heat capacity. Specific heat is actually, we will discuss that in the statistical and thermodynamics class. Specific heat is actually the heat given to the system upon the mass of the system into the temperature change in the system. It means that it is defined as that. We will discuss its definition in the statistical and thermal physics. Okay, it is defined as that if for 1 kilogram system, how much temperature is increased if we given means how much heat energy we have to give for 1 kilogram substance to rise its temperature by 1 degree. That is the specific heat. So its formula is heat given to the system upon mass of the system into change in the temperature. We have given q amount of heat, its mass is m, and when we given q amount of heat, its temperature is increased by delta T. So this is its formula. We will discuss it in a statistical and thermal physics. Okay. So here the dimension of specific heat capacity become the dimension of heat energy, dimension of energy upon mass into dimension of temperature. So dimension of energy we know that ml square t power minus 2. Dimension of mass is m, and dimension of temperature is theta. So here m and m get cancelled. Okay. So m power 0, l square t power minus 2, and theta power minus 1. L square m power is 0, so it is not written here. So L square t power minus 2 and theta power minus 1. Okay, that is the dimension of heat capacity. Another question, this is also asked, dimension of Planck's constant. We know that energy of a photon equal to h nu, where mu is the frequency. Here mu is a frequency, and frequency is actually, we know that frequency is one of the time, 1 by time period. Frequency is 1 upon time period. So dimension of frequency will be 1 upon t. So here a dimension of frequency is 1 upon t. So dimension of Planck's constant, look, h equal to e by mu. So mu we can write 1 by t also. So e by 1 by time period. So this become e into t. So dimension of energy into dimension of time. So dimension of energy ml square t power minus 2 into dimension of time t. So ml square t power minus 2 into t equal to t power minus 1. So this is equal to ml square t power minus 1. That is the dimension of Planck's constant. Dimension of angular momentum. We know that angular momentum is r cross p, or r is the length and p is the linear momentum. So length into linear momentum dimension, we will get ml square t power minus 1. Now we have to note some important point related to dimension that you must note to solve the problem. Okay, whenever we solve the problem, we note that the question will be different. I have here given all sample problem, model problem will be discussed here. First, before that, please note the dimension. If you write an equation, the dimension of LHS must be same that of the dimension of right side. Dimension must match. If dimension is not matching, then that equation is not correct. Okay, that formula is not correct. One thing you have to note. Another point you have to note that in the some question we have imagine like log alpha beta by 2z, or e raised to e raised to imagine e by kbt, or imagine we have sin kx by gamma, something like that, or log a plus b, log a by b. So here in this case you have to note that whenever you have this type of a function, a log function or an exponential function or a sine function, that term, the quantity in the bracket is dimensionless. That must be dimensionless. So dimensionless means its numerator dimension must be same that of the denominator dimension. For example, here dimension of alpha beta must be equal to dimension of z. Here dimension of e must be equal to dimension of kbt. Here dimension of kx must be equal to dimension of gamma. Here dimension of a must be equal to dimension of beta. So the numerator and the denominator have same dimension. So that dimension get cancelled. So the quantity inside the bracket have no dimension. So based on this also some question can be asked. So and sometimes they ask 4 option will be given and ask which of the following have same dimension, or 4 option is given which of the following have different dimension. Oh, and this type of question is given. So here I am actually given explaining the old model question. Okay, the first model question, this is one of the important, and this type of question can be asked in the CSIR NET also, not only just a set examination but NET also. Here question, look, if the velocity of light c, Planck's constant h, and the gravitational constant g are taken as fundamental unit, find the dimensional formula for mass m. So we have to write here mass m as the we have to write here mass m in terms of c, h and g. We have to write mass in terms of c, h, g. Okay, so how to write here? Mass have dimension. We can write here m equal to some constant into c power a, h power b and g power c. Now we can find the value of a, b, c. Okay, value of a, b, c. So here in the right side mass is m. So its dimension is m only. So m power 1, l power 0, t power 0. So the left hand dimension also, this quantity is c power a, h power a, g power c. This quantity also must have same dimension. m power 1, l power 0, t power 0. So we find the dimension of this quantity and equate it with this one. Then we will get the value of a, b, c, and that we will substitute here. Okay, so I am already included the detailed solution here to save our time. So we can write m is proportional to c power a, h power b, and g power c. And where c is the velocity of light, and its dimension is l into t power minus 1. And h is Planck's constant. We have already derived it, ml square t power minus 1. Planck's constant, look, ml square ml square t power minus 1. We have already done. I will show you. ml square t power minus 1. Okay. And g is a gravitational constant, m power minus 1, l cube t power minus 2. Gravitational constant. Gravitational gravitational constant, where we have done g. Look, m power minus 1, l cube t power minus 2. Okay, so that is the gravitational constant. Now substitute the left hand side. We have m power 1, l power 0, t power 0. Velocity raised to a, h power raised to b, and g power raised to c. Now look, here we can complete this. We can write in terms of mlt. Okay, mlt, m l t. Now take the m power here, m power 1. M power b. Here m power minus 1 into c. So b minus c. Let me write properly. First write m powers, m power 1 into b, m power b, minus 1 into c, so minus c. Okay, now let us look at l power 1 into a, 2 into b, so plus 2b, 3 into c, so plus 3c, and t power minus 1 into a, minus 1 into b, minus b, minus 2 into c, minus 2c. Right hand side, m power 1, l power 0, t power 0. Now compare both sides. So 1 m, compare m power of m. 1 equal to b minus c. 1 equal to, for m, 1 equal to b minus c. So we will get b equal to 1 plus c. Okay. And 0 equal to a plus 2b plus 3c. A plus 2b plus 3c equal to 0. And another here, 0 equal to minus a minus b minus 2c for t. So from this we will get a equal to minus b to c. We have 3 equations and 3 variables. Solve it. What we will do? Substitute one quantity in another. For example, look. Here we have b equal to 1 plus c. Here substitute the value of b. Here we will get a equal to 1 plus c minus 2c. Minus b. So minus 1 minus c minus 2c. So this become minus 1 minus 3c. Okay. So we will get a equal to minus 1 minus 3c. And substitute the value of a and b here. You will get both value. You will get the value of c. Okay, because now only one variable will be there. A you substitute in terms of c. B also you substitute in terms of c, and you have c only. Then rearrange the time, you will get the value of c, and substitute the value of c here, you will get the value of b. Substitute the value of b here, you will get the value of a. So here a will be 1 by 2, and b is 1 by 2, and c is 1 minus 1 by 2. I want to tell you, you people do this as a in your notebook. Okay, this is a basic 7th 8th standard school mathematics solving 3 simultaneous equation. Okay, just by using elimination method, write 3 equation, substitute one equation in another one, and solve it. That's it. Okay, you try it. So a power 1 by 2. So we will get a is 1 by 2. So c equal to c power 1 by 2 and chg. We have written first c power a, h power b. H power also 1 by 2. G power minus 1 by 2. Okay. So under root ch. Under root hc we can write minus 1 by 2. 1 upon under root g. So we can write under root hc by g. Very important. Sometimes the same question can be asked. Okay. Please note. Maybe in your examination the same question can be asked. So we can write the mass relationship is hc by g. Okay. hc by g. So this is a one way to solve it. Another way of solving this is a 4 option will be already given. So you find the dimension of all 4 options. Maybe if the first option is correct, you will get answer in a 1 or 2 step. You don't need to solve for A, B, C, etc. Already this option will be there. This option will be there. Look here, it is option, that option is there. C power 1 by 2, this option B. You try with this, substitute the value of dimension of H, dimension of C, dimension of G, and simplify it. If you are getting dimension of mass, first option will be correct. If you are not getting, that is incorrect, then try for second option. So in this way also you can try. Okay, other than finding the value of ABC, you can try with option A, option B, option C, or whichever option you want, you can start with it. If you are too lucky, your first try will be the correct option. Okay, another question is another very important question. In this equation, P equal to alpha by beta exponential minus alpha z by k theta, where P is pressure, Z is distance, K is Boltzmann constant, and T is temperature. What are the dimension of beta? We have to find a beta dimension. Look, I already told you the quantities in the bracket of exponential, log, sine, or trigonometric function is dimensionless. So the dimension of numerator and dimension of denominator is must be same. In the denominator, so here this quantity alpha z upon k theta must have same dimension, because this quantity is dimensionless. So alpha z must have same dimension of that of kbt. So alpha z and kbt or k theta must have same dimension. We know that k theta, if theta is a temperature, k is Boltzmann constant, we know that we usually write kbt, Boltzmann constant in temperature, that is actually thermal energy. So this have energy dimension. So alpha into dimension of z is equal to L, because it is given, it is a distance L, and dimension of energy is ml square t power minus 2. So what is the dimension of alpha? Dimension of alpha equal to ml square t power minus 2 divided by L. So this get cancelled. We will get ml t power minus 2, dimension of alpha. So that is the dimension of a force only. Okay, ml t power minus 2, mass into acceleration, dimension of force. So this quantity is dimensionless. So look, P equal to alpha by beta. So alpha by beta must have a dimension of pressure. Alpha by beta must have a dimension of pressure, isn't it? So and we know that pressure equal to force upon area. Force upon area. So here it is alpha by beta. We already know, we already derived that dimension of alpha in this expression is a force. So dimension of beta must be equal to area. So area means length into length square. So which option is correct? Look, L1 not square, incorrect option. Second one, m power 0, L power 2, T power 0. So here we have L square, other quantities are 0. So this option B is correct. Okay, so it's a detailed form I have here included. So in the PDF copy you can see it. Okay, with the detailed PDF is created, so you can easily go through the lecture. Next, another type question is which of the following quantities is not dimensionless? Note the point. Sometimes question will be like that. Which of the following quantity is dimensionless? Here it is asked which of the following quantities is not dimensionless. Okay. So the quantities which are dimensionless, when you write, imagine angle. So we know that angle is equal to arc by radius. Arc by radius. Okay. Arc is a length, radius is also length. So length by length cancel. So plane angle is a dimensionless quantity. Relative permeability, that is the permeability of a given medium upon permeability of a free space. Both have a same quantity. Both have same thing. One is the permeability of any given medium, another is a permeability of free space. So same thing, the dimension of both get cancelled. So this is also dimensionless quantity. Strain. Strain is, imagine the strain in the we know that in the, maybe you have already learned in the 11th standard, Young's modulus, shear modulus, bulk modulus, etc., in which strain is changing in the original dimension upon the original quantity. For example, strain in the length is a change in the length upon original length. So this is also length, this is also length, dimension get cancelled. So this is also dimensionless quantity. But specific heat capacity we have already derived, which have dimension. So which of the following is not dimensionless? That is a specific heat. Plane is a dimensionless. Relative permeability is dimensionless. Strain is dimensionless. This have this specific heat capacity have a dimension. Okay, so option C is the answer. This type of question asked in our examination. Another question, look, another model question. Which of the following pairs of physical quantities does not have same dimension? We have to check which quantities does not have same dimension. There are multiple quantities which have same dimension. For example, let us check the dimension of work and torque first. We know that work is equal to force into displacement, and torque is F dot S. This is R cross F. That is also force into displacement into force. Work is a force into displacement. One is dot product, another is cross product. That F dot S means Fs cos theta. R cross F means R into F sin theta. And I already told you that this cos theta, sin theta, log e raised to x is a dimensionless quantity. So this quantity both is a force into displacement. So work and torque have same dimension. Next, impulse and momentum. Impulse is actually force into change in the time, but it is actually, if you know actually the concept of impulse, impulse is actually final momentum minus initial momentum. That is actually change in the momentum. So impulse is have a dimension of momentum, and momentum also have a dimension of momentum. So both have same dimension. Okay. Now light year and wavelength. We know that light year represent length and wavelength is also represent length. So this also have a same dimension. Impulse and moment of force, that is different. Moment of force is actually a concept of torque. So torque and impulse, impulse is, we already know that impulse is a dimension of momentum. So momentum and torque or moment of force is different. So momentum, impulse and moment of force have a different dimension. Okay, so these are the model questions that we can expect in our examination. So our dimensional analysis class is over. If you people have any doubt, you can share your doubt in our group, and otherwise you can directly message it to our official WhatsApp number. Okay, so this class is over.